Hello guys, so we are back again, and in this session we are going to end the implicit function which we have started from the two previous lectures. So before starting with the implicit function last part, I want to say please subscribe the channel so that we can bring more engineering content for you guys. Okay, now let's begin with the questions. The question which we are going to take is as follow. This is the question which we are going to take. If phi bracket xy square comma z minus 2x bracket equals to 0, prove that 2x dou z by dou x minus y dou z by dou y equals to 4x. Now how to begin with this question? Here, by observing this, that dou z by dou x and dou z by dou y, I can make out one thing, that x and y are independent and z is dependent on both x and y, and my phi is the central function. So what our steps will be: first, since they have not given any middle function, we have to call it some middle function. Let u equals to xy square and v equals to what? Z minus 2x. And you can say from the given proof, we can make out that x and y are independent and z is dependent on x and y. Now what we can do after this step is just do this thing, that phi was what? Y square minus z minus 2x equals to 0. But what you can now write, phi equals to u comma v equals to 0. Now this is our implicit function. As per the definition, f of x comma y should be equals to 0. So we have considered this so that our differentiation becomes easy. Now if we observe, we want dou z by dou x minus y into dou z by dou y. So what we can do is we can differentiate u and v. Then we can get what? In between u there will be surely be here, if we differentiate it with respect to x and with respect to y, there will be dou z by dou x term involved if I differentiate it with respect to x and with respect to y. Okay, so let's partially differentiate. First, let's our main function is what? Our main function is not z, our main function is phi. If I differentiate phi, there will be movement. Okay, listen, phi is what? Phi is a function of u and v, which we assumed. Then u is a function of x comma y, and v is a function of z and x, and we want z involved in it. So what we can do, if I partially differentiate phi with respect to x. If I do that, what I'm going to get? Dou phi by dou x. It will be nothing but, if I differentiate it, dou phi by dou x will be, if you observe, dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou y. You can make out this thing. Now what value I want? I want the value of dou u by dou x, and I want the value of dou v by dou y. From where I can get this value? I can get this value from this equation of u and this equation of v. So partially differentiate u with respect to x. So if I do that, dou u by dou x, which I will get will be nothing but y square. And similarly, what I can do, partial difference v and u with respect to x, then I will get dou v by dou x also, which will be, now remember z is dependent on x and y both, so it will be dou z by dou x minus 2. So now we will substitute these values in 1. Put the values in equation 1. What we are going to get? We are going to get dou phi by dou x, which will be nothing but dou phi by dou u. Dou u by dou x is what? U y square into dou phi by dou v into dou v by dou y. Dou v by dou y, sorry, dou v by dou x. Dou v by dou x is nothing but dou z by dou x minus 2. Okay, I just did a mistake. I called it 2. Minus 2. Now what we can do here, after getting this, we know that the function, okay, if I differentiate this function, it should also be equal to 0. So this will be equal to 0. If it is equal to 0, then what we can do, put dou phi by dou x equals to 0, because implicit function is always equals to 0. So its differentiation will finally end up giving me 0. So I am putting it equal to 0. Now we are getting dou phi by dou u into y square plus dou phi by dou v into dou z by dou x minus 2. We will move it that side, or we will move this that side. We are going to get 2 minus dou z by dou x into dou phi by dou v equals to dou phi by dou u into y square. If I move this value and move this value here, I am going to left with 1 by y square into 2 minus dou z by dou x equals to dou phi by dou u the whole by dou phi by dou v. Let's call it 1. Because my main target is to get dou z by dou x, okay, and I want to eliminate this stuff. But for that, what I will do now, I will get partially differentiate phi with respect to y. To get what term? To involve dou y by dou z by dou y. Partially differentiate phi with respect to y. So what I am going to get, dou phi by dou y, which will be dou phi by dou u into dou u by dou y plus dou phi by dou v into dou v by dou y. Now let's call it, this was 1, this is 2, this is 3. So what we are going to do, we are going to get dou u, but before that, partially differentiate v and u with respect to y. If I do that, I will get dou u by dou y equals to what? 2xy, and dou v by dou y as dou z by dou y, and this value will become 0. Now if I put the value here, I am going to get dou phi by dou y equals to dou phi by dou u. This value is 2xy, this value is 2 phi v into dou z by dou y. Now this should be equal to 0 since it is an implicit function. If it is so that, then I can move this here, or we'll move whatever we want, minus dou z by dou y into dou phi by dou v equals to dou phi by dou u into 2xy, right? We'll move it here, we'll move this that side. So what I'm getting up finally is minus dou z by dou y the whole by 2xy should be equals to dou phi by dou u into dou phi by dou v. This is what, this is 4. Now equate, since they both are equal, we can equate them, or you can divide them, it's up to you. So equate equate 2 and 4, we get what we get. If we equate, we are going to get something like 1 by y square 2 minus dou z by dou x is equals to, if I equate this is minus times dou z by dou y 1 by 2xy. X, y will cancel out. This x will move here and 2 will move here. So I am going to get 2 x will be here, 2 minus dou z by dou x, right? Here minus dou z by dou y will be as it is, here it will be y. Now if I multiply 4x minus 2x dou z by dou x is equals to minus y dou z by dou y. Now what we wanted to prove? We wanted to prove 2x dou z by dou x minus y dou z by dou y. So what we are going to do? We are going to move this that side. So 2x dou z by dou x minus y dou z by dou y equals to 4x. So we had proved what we required, hence proved. Now let's move on to the next question. Hope you understand. Okay, just you should know this chart. Okay, if you should draw this chart, you will automatically able to know what we want to do. Just you have to make out that z is dependent on these things. Okay, and these, how to identify this type of question? They will never ask you directly dou z by dou x or dou z by dou y, in which we used to apply the formula minus fy upon minus fx, minus fy upon fx, minus fz upon fy, like that things. And it, one other way to identify, you can directly make out that it is an implicit function. Okay, which is one more a significant proof that you are going to use implicit function. Just identify the implicit function. That's why it is taught that how to identify implicit functions. Now let's take the next question. So the next question is as follow. The next question which we are going to take is this one. If phi bracket z by x cube minus y by x bracket equals to 0, prove that x dou z by dou x plus y dou z by dou y equals to 3z. Again, this is a similar kind of thing. From here you can make out that z is dependent on x and y and z is dependent on y. So let's first, what is your job? Let x by cube equals to u and y by x equals to v. After doing this, what you can do? You can draw the chart. Phi is our main function, u and v are the middle intermediates, and after that u is what? In terms of x and y, sorry, u is in terms of z and x, and v is in terms of y and x. I want dou z by dou x, I want dou z by dou y, so I need to involve both of them, right? So what we can do is, after doing this, we have to mention that the dependency from the above proof we can make out that z is dependent on x and y variable, while what? X and y are independent. Now what we have to do? Partially differentiate phi with respect to x. What you are going to get? Dou phi by, okay, before doing that we should mention one more step, that was phi was z by x cube minus y by x, which was equals to, which will be modified now, it will be u comma v equals to 0, and it is also implicit function. Now if I do this, dou phi by dou x will be nothing but dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou x. If I do that, I need to get this, so partially differentiate u with respect to x, sorry, v and u with respect to x. If I do that, I'm going to get dou u by dou x is nothing but, now you can use quotient rule and product rule, both will work, it's up to you. X power the whole square into x cube dou z by dou x, this will become minus, it will be what, here it will be z as it is, and if I differentiate 3x square, right? If I simplify this, I'm going to get dou z by dou x 1 by x cube minus 3z by x raised to 4. After getting this, what I'm going to do, we are left with this thing, let's call, okay, we'll substitute here, but now get dou v by dou x. Dou v by dou x is just simple, it will be minus y by x square, not a, now let's substitute. If I substitute, dou phi by dou x will be what, dou phi by dou u into 1 by x cube dou z by dou x minus 3z by x raised to 4 minus dou phi by dou v. How minus came? Because this is minus, into y by x square. Now this will become 0, so I'm going to shift this because it is minus sign. So I am going to get dou phi by dou v into y by x square. I will put this value equal to 0 since it is an implicit function, and I have told you the reason of putting it equal to 0. 1 by x cube dou z by dou x minus 3z by x raised to 4. After doing this, what value I need to equate? I need to get rid of these two values. So I am going to, this time I am going to take this thing, dou phi by dou v by dou phi by dou u. Why? Because this thing is quite big to take in denominator. So my intention will be dou phi by dou v by dou phi by dou u. Take this in, and here I will get rid of x square, okay, and x square from here. So finally I am going to be left with 1 by y dou z by dou x. Here it will be x only, 1 by x. It will be what? 1 by x. Okay, so here we will be left with 1 by x dou z by dou x minus 3z by x square. Now I got this value, I will call it some a. Now what we are going to do, partially differentiate what, phi with respect to y. What I am going to get, dou phi by dou y, which will be nothing but dou phi by dou u into dou phi by dou u by dou y plus dou phi by dou v into dou v by dou y. Now what I want to get, I will do partially differentiate u and v with respect to y. If I do that, dou y by dou u by dou y, which will be nothing but, if I do the partial differentiation, it will be 1 by x cube will be outside and it will be dou z by dou y, and here it will be dou v by dou y, which will be nothing but 1 by x. Let's put the value, dou phi by dou y should be equals to dou phi by dou u. Dou u by dou y will be nothing but, I can put this value 1 by x cube dou z by dou y plus dou phi by dou v will be nothing but 1 by x. This will be become 0, which will shift here. So I am going to get dou phi by dou u with a minus sign 1 by x cube dou z by dou y equals to dou phi by dou v into 1 by x. Now my main target will be what, to get dou phi by dou v. I will shift this value here and get this value here, but before that x will cancel out, and finally I am going to left with x square. So 1 by x square into dou z by dou y, which will give me finally with the minus sign will be equal to dou phi by dou v the whole by dou phi by dou u. let's call it B. Now what we have to do, equate A and B. What we are going to get, we are going to get something like 1 by x square dou z by dou y is equals to we are going to get from the A, which should be equal to 1 by y, 1 by x dou z by dou x minus 3z by x square. So what we are going to do is get rid of this x square and move this minus inside. So dou z by dou y will move here, further here x dou z by dou x with a minus sign, and plus 3z will be left. So if I simplify, what I am going to get is x dou z by dou x plus y dou z by dou y is equals to 3z. Hence proved. So these were the last type of question which you will come across in implicit functions as far as the syllabus is concerned of GATE or whatever of your college. So we are done with the implicit function. In the next session we are going to start with the Euler's theorem in that we will study homogeneous functions and some more new interesting things. So till then, revise all the things which we have done. We have covered a large variety of questions in partial differentiation, and probably this is going to be the end, because only Euler's theorem is left, and the one more other part of the partial differentiation is maximum and minimum, which is separate thing. Okay, but revise all these things. See you in the next lecture. Thank you.